So I'm going to give you a little bit of an idea of what this session is about, and then we're going to get started. So I thought it would be cool to see where we came from and where we're going, kind of. So this is going to be three talks, followed by, if we have extra time remaining, potentially us sitting here and telling stories about our first sitcoms. It's inspired a little bit by the Moth personal storytelling. We're going to start with what happened when the Gal Rexford paper was written, move along to talks from the past sitcom from both Kenneth and Minlan, and then we'll end with basically everybody else chiming in and telling stories. Feel free to ask questions after each talk. And with that, I'm going to introduce Lixin. Lixin Gao is a university distinguished professor of electrical and computer engineering at the University of Massachusetts at Amherst. She received her PhD degree in computer science from the University of Massachusetts at Amherst. Her research interests include internet routing, network virtualization, and cloud computing. Between May 1999 and January 2000, she was a visiting researcher at AT&T Research Labs and DIMAX. She was an Alfred P. Sloan Fellow between 2003 and 2005, received an NSF Career Award in 1999, and a fellowship from Harvard University Radcliffe Institute in 2002. She won the Best Paper Award from IEEE Infocom in 2010 and the Test of Time Award in ACM SIGmetrics in 2010. Her paper in ACM Cloud Computing 2011 was honored with Paper of Distinction. She's a fellow of IEEE and ICM, and I'm sure most of you grew up learning about her work, so with that, Lixin.
Okay, so thank you for the introduction. I sent you the whole bio, but I thought you could just pick something, especially about, something related to this. Okay, so this talk was actually presented in SIGmetrics. And then, later on was more mentioned in SIGCOMM', but I was never presented here. So thank you for the invitation. I got a chance to present this talk. But I did revise the talk quite a bit because I don't have the original talk. So I sort of go through the years of comments and get a collective wisdom from ChatGPT and see what exactly people are saying about this. Okay, so so the story started with a curious question. Basically, how does internet work? Internet routing work, rather. So I check around, that was back to 99, I check around with people and see what exactly going on with all these routers and how they work together to forward packets. Okay, so so we can go to next slide. Oh, do I have control here? Okay, so I check on a textbook and all that. And so the only thing we know about that point was Dijkstra. So then I asked questions about, well, we know how to do this if we know the topology, okay? And if we know the cost, right? Because we have an algorithm, okay? And in fact, later I find there are protocols, right, to do that as well. But it turns out we don't know topology. In fact, I did ask many people what exactly internet topology looks like at that point. People said, we don't know, okay? And then when I was doing this when I was at AT&T in sabbatical, and so I was, Jen was saying, maybe I can show you how AT&T, the cost is set up, okay? But in fact, I don't know the topology. I have to really work hard to get topology as well. Okay, so so that was I get more and more questions from that on, so I don't really understand anything. Okay, so then slowly it comes to me. There's much into it. It's not Dijkstra. So this whole thing is lots of bubbles. Okay, so lots of bubbles. They are all managing their own thing. Nobody, they talk to each other, but they are really working on their own network, okay? And this thing called, basically, they manage the network with the more or less Dijkstra or some shortest cost path routing, then they talk to each other with this thing called BGP. Okay, and that was the first time I realized it's BGP, working the magic. Okay, so so how does BGP work? So basically, they talk to each other. They tell partial stories, right? They only tell what they see, and they and they only configure the network based on their own need. They don't really know anything beyond their own network, or they only hear about things from neighbors, but they don't really know beyond that. Okay, so that's what I learned. Okay, so that was actually easy, right? Because, well, we know how we can send protocols. That was a good story and simple. Now, so this is what I see next. It's a mess, basically. So this is what cracked leverage and a bunch of papers. I studied inside all of them. But basically, it shows that BGP doesn't behave in real life. They are basically, all this noise going on, in the BGP sort of the messaging system, and it's kind of scary, right? I mean, we will say that it could get worse and worse and worse. Eventually, internet will melt down. Okay, and so. So that was a bit disappointed. Okay, so next I have even worse news. Okay, so there's this theoretical analysis about how BGP can behave. Like what's the worst case, right? So basically, this thing called Tim Griffin and all basically come up with this bad gadget. And it says that if you have something like this in your network, okay, and it's going to be, the route never really converges. It's figuring out what's going on, and it's trying to figure out what's going on forever, okay? And in fact, what they're saying is that if you have any one of these, anything like this, okay, it's a huge. Right now, it's only 3-node example on the rim, but you can imagine have n of those or 5 of those, whatever you have. Any of those are really bad. Okay, you don't want to have any of those. And the key corpus of this, of course, this topology is an obvious thing, but the key corpus is their policy is somewhat conflicting. Basically, you don't have the right kind of policy. And that policy is basically saying, I prefer you, and you prefer somebody, and somebody also prefer you. So there's some kind of cycle going on there, okay? And to make that decision, even though I have all the policies of everyone, right, I have to really, this is a very hard problem, computationally hard, NP-hard problem. So I cannot, even you give me all the whole topology, all the policies of the networks, you cannot easily determine whether BGP converges. Okay, so well, we have some kind of weekly chatting for a while about this thing, and we are kind of every week we talk about this. Me and Jen was talking about this. We get depressed, and we don't know what to do. It's like, ooh, this is BGP, and we're using it, and it doesn't. We don't know what to do with it. So, and then one day, we thought, okay, let's think about some good news. Why does BGP work? Why people are still using it, right? So, so here's the question. So why we even use it until today, okay? So, these are some high-level things we thought about, and then to be able to kind of realizing what we can do to make each network do their own thing, do their own configuration, and be able to still guarantee global coordination. Okay, So I'll get to that, how that works in a second, and I know you know as well. So, but before that, let's ask, well, I wish I have ChatGPT then, because so let's ask ChatGPT what ChatGPT says about BGP convergence. Whoops. Okay, sorry. So basically, if you want to make BGP stable, right, well, ChatGPT has the following answer, right? So, well, actually, it's pretty nice. There's 9 strategies, okay? Route filter, route aggregation, route preference, route stability, security measure, redundancy, failover, coordination, collaboration, blah, blah, consistent configuration. Wow, that's all good stuff. Then there's a separate bullet, right? I mean, by the way, I shrink all these bullets because I didn't want to clutter the whole thing. Oh, it's already cluttered. And then there's a separate bullet. I don't know what this relates to, these 9 strategies. There's this Gall-Rexler guideline, okay? And so that's pretty good. Well, I wish I had this name in my paper. Then there's this 3 bullet saying about relationships. And then this relationship is about, like, then they talk about preference and advertisement and all that. Okay, so this sounds familiar. So I thought maybe I should ask ChatGPT what Gall-Rexler guideline is. So maybe I can get more details. This is a little bit, hard to comprehend what exactly going on with relationships. So, oops. Okay, so, wow. So this is what ChatGPT says. In fact, I didn't shrink this as much. Basically, this is very well organized bullet. It's about the global topology property, number 2. And then the number 1 is about preference. And number 3 is about export rules. And they are all good stuff. They are perfect. And even there's something about implication of this. How does it, imply, so in fact, it talks about ISP follow this, network operator, and achieving stable and efficient routing. Okay, so the next thing I did is I basically asked can you translate this thing to PowerPoint, okay? And in fact, ChatGPT did, basically going through the text and chopping them into, each one of them into 1 slide. So that's what I get. So I said, okay, maybe I have to recreate the slides. So this is what I have. Okay, so the key thing here is that I do not want to have coordination among ISPs or networks. And I want to be able to still configure my network and, and ensure global stability. And the key thing here is that we recognize the relationship between these ISPs, the economic relationship between these ISPs, in particular, provider-customer, peer-to-peer. And we do notice that it's debatable. There are some loops, but provider-customer links will form a hierarchy with basically so-called there's no cycle, right? So it's hard to by transit and then to A, and A by transit from B, and in turn B by transit from you, right? So you would not. So this is really a hierarchy lead. Obviously, this is an example how this hierarchy looks like. With this, what we can do is we can set up our policy individually, locally, and ensure stability. Okay, so here is the policy. Oops, I don't know what happened here. But I think you can figure out, oops. Oh, yeah. Okay, so let's talk about what kind of path is possible. And this is really export policy. So essentially, no valley. Okay, so what is valley? Valley says, oops, I missed. Okay, so if you go down, which means you go to customer, and you cannot come up. Okay, so this is a valley path, and should never be there. And similarly, I mean, this is also a valley path visually, but in a way says that you cannot use peer links as your sort of the transit link, and then you go down, you go up to the transit link again. So there are a lot of variations like partial links and partial path is not allowed, and those are also approximately valid path. Then this is the export policy. Then you have import policy says that prefer customer. Always prefer customer. Everything else is secondary. Okay, so these two is going to give you stable routing globally. Okay, and there are variations of this, obviously. So if you have more constraints about the topology, for example, if you can squeeze in all the peers together and you still have hierarchy, you never have loops, for example, then you can relax about what's going on at the preference part. So you can even prefer, you have the same preference appear with customer, have the exact same preference, that's fine. Okay, so there are variations about this, but this is the base of what's going on. Okay, to enable. So there's the key thing here is there are economic incentives to follow this. There's no reason unless you have, of course, we know nowadays it's possible to have private peering and all other special sibling kind of agreement, right? So you can say, well, I help you, you help me, but only for using our transit, not for anything else. Okay, then those things potentially can be arranged. But all in all, you want to use something like this in general, to enable global connectivity, to the stability. So I don't know how much more time, but I have one more slide, 1 minute. Okay, I just want to say a few things about, this is very much the last thing. So following on this, so SIGCOMM has been like, right after this was published in 2001. In 2002, there was a session about IBGP routing stability, how to ensure that, right? So it was very much on the spirit. How can you, so what I talked about is basically eBGP, the policies, and how can you guarantee stability. But here we're talking about IBGP configuration and how can we guarantee stability, okay? So, and then we and, of course, many others, including more recent work, is talking about how can I get the relationships just from BGP data, right? And if I, then now, probably we know topology, we also know who is the big provider, right? And who is the access network. And there are, amazing amount of work about, how can you describe policy using routing algebra, traffic engineering, where you want to figure out, based on the kind of peers you have, how do you set up your traffic engineering policy? And there are also configuration that how do you verify whether your policy conform to GovRexford? So this is a sample. Clearly, I haven't listed out anything. I was just listing out some of the things that come to mind. But there are a lot more. I might miss many of those. Okay, with that, thank you for listening. By the way, when I gave this talk, there was really, at that point, people heard about BGP and they were asking how that works. There was not really a question. And then Christopher Deal was a session chair. He said, yeah, we need to understand BGP. That's all. So I'm glad I get this talk to hear because I can get more questions.
Yeah, and actually we have 2 minutes for questions if anybody wants to ask Lixin questions. Otherwise I'll have,
Okay.
I have a question.
So given the complexity, as you've just described, and the fact we maybe even still don't fully understand it, you started talking about verification at the end as well. How do you feel that's going, given all of the background that you have and knowledge that you have? Do you think it's, how is that work going?
Yeah, so that's a great question. So in fact, some of the work we're doing right now is looking at how can I explore the fact that these relationships that we can really verify. So most of the verification techniques assuming no knowledge, just using configuration. So in fact, we have an InfoComm paper this past year about how can I explore this hierarchy to make sure that we can verify some of the policies faster, right? So basically, we can really explore the fact that it's not simply, exploring the routes, but how the routes come about based on how it converges, okay? And I know many people trying to use it as a way to understand what kind of policy you should have, and make sure you don't get out of line about, what you're verifying.
Hi, I have a more research advice type question. Did you know that this work would have this impact? I don't know much about BGP, but if there's one thing that I learned from my graduate networking course about BGP is value-free routing. So how do you feel about your work appearing on ChatGPT and ChatGPT, like you're literally answering, summarizing your research after like 20 years?
Oh, thank you. So in fact, it was just like 2 days ago I did this experiment. I've never done this. So I thought, when Bernard asked me, I said I should understand what's going on the past 20-something years. So, if any grad student here, my own feeling is that I always started with question with basic curiosity. Basically, I want to really understand this. Then you can get to the bottom of it, right? And I've never thought about, this is going to get to this, and whether it's going to get SIGCOMM', right? It's going to get to SIGCOMM' if it's really there. So the way I thought about this is like, I really want to understand something, and how can I understand this? I'm certainly happy about people talking about GalRexfer even yesterday. Scott was saying that, but I never thought about that. It was never, I guess, it's not predictive. And even people who doesn't really, I think, a lot of things is really out there, and you can just go for it. You don't have to worry about what it's going to be. Is this going to be a big one, right? So even my grad student, I tell them, like, don't worry about now. Let's do it and see what happens.
Thank you. It's great that you had this session here.
Thanks.